I'm Robin Moore, and I'm a senior in electrical engineering here at UAB. And for our project, we did an autonomous block sorting robot. Okay, essentially, in a lot of modern packaging facilities and shipping facilities, they have robots that will go and find packages. So our robot is essentially a small-scale mimic of the processes that are involved. So we have different size blocks that will go on this course here, and based on color and size, we sort them to their respective areas, and we get points based on whether we get them in the right color and the right size space. Yes, it is very much a game. It's a very complicated game, but it's a lot of fun. We can't control the robot once we hit go. It has to do everything on its own. So it just hit go and runs through the course and tries its best to sort the blocks. Well, we've got these little pre-built circuits that have some LED lights on them, and it shines the light on the blocks, and then whatever is reflected back, it reads that and then determines based on how much of each kind of light comes back what color it is. And so we've got 3 of these all on the robot. We've got 2 on the arms and a separate one that goes down to the floor, and that one will pick up the spaces colors, and then the ones in the arms obviously pick up the blocks. It's a culmination of all the things we study in electrical engineering. We've got programming, obviously, we've got circuits, we have power systems, we have a lot of things that we never even thought we'd get into, like mechanical design. But a lot of engineering these days comes from a bunch of different fields, and you have to learn how to work with different fields of engineering, so understanding concepts from different fields is really good for students in all engineering types. And specifically, we did this for Southeast Con 2013, which is an IEEE competition/meeting, and it's an international organization for electrical engineers. Out of all the schools, there were 40+ teams, and we got 10th overall. And then in the open competition, which is available for everyone who's a member of IEEE to join, we placed 2nd. I'm most proud that we got it done despite all the drawbacks. This problem was really difficult to solve. It's a lot more difficult than competitions have been in the past, and so there were a lot of hiccups along the way, and a lot of the teams had trouble, and the fact that we got our robot together enough to where we could actually place at competition, we were really proud of that. The value of undergraduate research is huge. Essentially, you get experience in your field that you can then take forward to jobs, and they know that you have worked with things rather than having just a textbook understanding. You have a practical understanding of the knowledge involved in your field of study. I would tell them to find professors that are doing things along the lines that they're interested in. A lot of universities have pages up with all professors' work on them. You can go and look through and get involved in as much undergraduate research as you can without hurting your studies, obviously, but it's invaluable when it comes to going on into your career after college.
Okay, so obviously we don't have the regular course, so I've got a mini demo set up, and what it's going to do here is it's going to seek out the blocks. It's going to skip the first one actually and go to the second one so that it can pick them up faster. And whenever it closes the arm, it actually incrementally grips 4 to 3 to 2 inches to determine the size. These are both 3-inch blocks. So, and typically on the course, the blocks will be spaced about 1 inch apart, but we've really made it a goal of ours to make the design robust, so we can actually move the blocks further apart and still get them. It actually will seek out the blocks. And then it will set them down. Now, we were talking about how it incrementally grips to determine the size, and you can actually see that. See here we have a 2-inch block, and what it actually does is, to demonstrate that it actually does know the size, it's going to reject the 2-inch block. It's going to just decide not to get it. We'll actually put it on the second arm to make it a little more complicated for it. But as you can see here, it'll drive, find the block, and then when it grips, it figures out that it is a 2-inch block.
That's awesome.
So, and actually, the time between the grips is so fast that you really can't see it. Approximately 1/10 of a second. So the robot processes a lot faster than we can. Yes, I do. It's actually pulled up right here. And it's approximately 3,000 lines of code. Now this little demo is probably about 100.